Linear functions and slope is the concept in section 1.4 here. So some bullet points and some things that we need to make sure that we touch on as we work through this. So we need to know what is slope formula. That just has to be memorized. We need to know the types of lines. All right. You need to know Pointslope formula. Slope intercept. And then the general form of a line. And then we'll do an application problem. Okay, so to get started, okay, so we have a line passes to 2 points, 0, 3, and 4, 6. We've got that. Okay. So first question. How many points are needed to describe a line? 2. You gotta have 2 points, right? So if you know the 2 points, you can describe a line. What is the formula to calculate the slope of a line? All right, so the slope formula, the slope, we use what letter for that? M. And it's change in y over change in x. So we use the symbol delta in math to represent change. But how do you calculate change in y and change in x? More specifically. Yep. So you y2 minus y1 over x2 minus x1. So you use the second quantity minus the first quantity, and there's your change in y and change in x. So now all you gotta do is just know the points and just plug and crank, right? So really there's no compromise on slope formula. It's just something as a math student that we have to memorize. Okay, so change in y over change in x, and that's it. So go ahead for this line, calculate the slope and see what you get for this line. And then we'll talk about kind of what slope tells us. Okay, and then there's like an application of slope too. I would probably just put my computer to the side and take notes. All right, so what do we get? What's the slope? 3/4, right? You should have got 3/4. So 6 minus 3 over 4 minus 0, you get 3/4. So what does slope, what does it tell us about the line? Yeah, I mean, we can say rise over run, right? But it came out positive. What does that tell you? Yeah, up 3, right 4, but like in a different way. It kind of gives me the how the line is kind of slanted. The fact that it comes out positive tells me what? It's increasing. It rises from left to right. So if our slope is positive, you know it's going to rise from left to right. If the slope is negative, we know it does what? Falls from left to right. So this is technically, that's called increasing, and this is decreasing. To the y's are dropping, right? What are the other 2 scenarios? There's 4 scenarios for slope. Well, if it's not rising or falling, what is it? Yeah? Slope is 0, that's for a horizontal line. Okay? And just to prove that, let's just say we took a line here, 0, 3, and let's say the other point was 4, 3. All right, we had this line. Just to prove that the slope is 0 for that line, 3 minus 3 over 4 minus 0, you get 0 over 4, which is 0. 0 over any non-zero number is 0. Okay? The bottom cannot be 0 in order to get the answer 0. Make sure that we're clear. 0 over any non-zero number is 0. Okay? What's the fourth situation? Vertical line. What's the slope for a vertical line? It's called undefined. That's how you write it out. I just usually put UND. That's a vertical line. So if we go over here, we look at this line here through these 2 points. All right. We're going to show that the slope is undefined. So if I look at that green line there, it's 6 minus 3 over 4 minus 4. So I get 3 divided by 0. So when only the denominator is 0, your answer is undefined. Okay, when only the denominator is 0, we say undefined. Okay, non-zero divided by 0, undefined. And those are the 4 scenarios for your lines. Okay. Everybody ring a bell? I mean, a lot of this is just getting the dust off, right? Just remembering all this. Okay. So then there's a couple of uses, or a couple of, for those 3 formulas there. So we've got our slope formula, we got our toxic lines. So basically, each of these is a way to write the line, and it has a use, or it has a preferred reason why we want the line in that form. So I'm going to start. I kind of wrote these out of order. I'm going to start with this. What good is slope-intercept form? You know, what do we use that for? So first of all, what is the slope-intercept form of a line? For 500 and negative 500 bonus points. Y equals mx plus b. And it's not rocket science, it's because m stands for the, and b stands for the. So for me, the easiest use of this is for me, it has 2 uses. Good to graph, and it's good to evaluate. It's good to get your y's out of this form because it's already y equals. So you can evaluate. You can plug your x's in and get your y's quickly. But for me, it's the best thing about it is graphing. So let's just say I have y equals 2x plus 3. That's our linear function. Okay? So is this in slope-intercept form? Yes. Why would I say it's easy to graph like this? Yeah, so literally we know the y-intercept is what? 3. So we know that 3 is the y-intercept. And then this 2 is really 2 over 1. And what were you saying that this meant? This means you're, yeah, go up 2. So if I go up 2 from here, that puts me up to 5, but I also got to go how far? 1 to the right, because it's 2 over 1. And that then gives you another point, because you know that just has to keep happening forever. That's the slant of the line. That's the slope of the line. So there you go. So it's very easy, in my opinion, to graph. There's our 2 that we rose. There's our 1 that we run. So it's useful to graph. And then if you want to get outputs, you can. You just plug in. Okay. So any question about that? All right. So typically, what you're going to be asked to do, you might be given a slope and a point, not necessarily the y-intercept, but you need to find the equation. So maybe I'm given this. So we'll call this example 1. Given a line with slope m equals -2 and passes through 3, negative 4, find the equation of the line in, and we're going to do two forms. First, we're going to do point slope form, and then we're going to do slope intercept. Okay. So now I'm going to kind of go through point slope formula and what it's used for, the point slope form of a line. I call it point slope formula because I use it more as a formula, more than a form of a line. Okay, so we're going to do two parts. So we're going to look at point slope formula and then we'll put it in slope intercept form. All right, so I'm told the slope and I'm told the y-intercept. I'm sorry, I'm told a point, not the y-intercept. Notice I don't have the y-intercept here. So now the question is, who here knows the point slope formula? Oh, I gotta put the slope formula up here. Who knows the point slope formula? Point slope. All right, so this is point slope formula. This is one, we use this one more than anything in calculus in terms of after slope, we use this. Y minus y1 is m times x minus x1. That's the point slope formula. I'm going to tell you exactly what I use it for. And we use it on a weekly basis in calculus. Every week or even every couple of days we use this form. What this is used for is, it's a formula to find the equation of a line, okay? It's a formula to find the equation of a line. So it just basically says, if you plug in slope and the point, so the slope, I'll just kind of underline what we're going to plug in. If you plug in the slope of the line and the point x1, y1, then now you have your y and your x and you can solve for the equation of the line, okay? And you can put it in slope intercept form. So the formula here, the point slope formula is used to find the equation of a line if you know slope and a point, okay? If you know a slope and a point. So it's really just a plug and crank. So y minus y1 is m times x minus x1. So using this information that I've given you, I'm going to point, you're going to tell me what to put there. Okay? What goes here? Just y, nothing. What goes here? Negative 4, so I'll go ahead and make it minus negative 4 and then we'll change that. What goes here? Negative 2, x minus 3. Very good. So now you see that you have an equation. It's just y is not by itself, but you still have an equation because you have x and y. So if I solve for y, if I get y by itself, guess what form you put it in? Slope intercept. Now it's back to that useful. So the point slope formula is typically used to find the equation of a line when you know a point and a slope. Okay? And then I solve. So how would you simplify this and put it in slope intercept form? So this is point slope form. Not pretty, but that's it. Okay? I can stop there because I can easily see the slope and a point on the line. But then what would you do? Yeah, distribute the negative 2. I make this y plus 4. This becomes what if I distribute the negative 2? Negative 2x plus 6. Very good. And then what's the last step? Subtract 4. And now you've used your point slope formula to write your line in slope intercept form. So that's point slope. For obvious reasons, this is slope intercept. What's the use of the point slope formula? To give you the what? To give you the equation of a line. You can then write it whatever form you want. This is the equation, it's just not pretty. There, and then you can put it in slope intercept form if you want, okay? Does that ring a bell? Okay. So when I said point slope, like I didn't see any sparks flying, like it seemed like, you don't know that one. Slope, you know. So let me show you a little trick. Ready? I'm gonna write slope formula like this, if that's okay. Doesn't matter which side I put the M on, does it? That's still slope. Just rotate with it, all right? Ready? I'm just gonna erase those twos. Cross multiply. There's your point slope formula. It comes from the slope of a line. If you know the slope of a line and you forget this, just go to your slope formula, cross multiply your x's. There it is. That's free of charge. Okay? There, that's where it comes from. If you make 1 point arbitrary, now you have your equation. You have to have your two variables. So this comes from slope formula if you just make that an arbitrary, not a two. Make it a variable. Okay? All right, I'm gonna point, you're gonna tell me the use. What's the primary use of that? Good for what? Graphing and also, yeah, evaluating. Give me an X, I give you the Y. What do you use this for? Finding the equation. You just need to know a slope and a point. What if I just give you 2 points? You find the slope first, good. So you may get something like that, okay? General form of a line, okay? All right. What is general form of a line? So general form would be ax plus by plus c equals to 0. Or the c could be over here. So this constant could be over here. It may be on this side, doesn't matter. But the x and y are typically on the same side. Maybe the c is on the other side. So I'll give you an example, and I'll put the c on the other side and I'll show you what it's for. 3x plus 4y equals 12. Let's say that's what we have. Okay. So just to make sure we go over some words here. Here, just so you understand, y is expressed implicitly. What do you think is the translation of that word implicitly? Y, on this equation, y is expressed implicitly. What's different between this and slope-intercept form? Y isn't by itself, that's all it means. Y is in there, it's just not, you haven't solved for y. All right, so I just want to make sure we're clear. Typically what we use this for is to get x and y intercept very quick. You can get the x-intercept and the y-intercept pretty quickly. So remember, x-intercept is x comma 0, right? There's an x and then the y is 0. And y-intercept is x is 0 and then we get a y. Well, see, here's all I do on this. Especially when both of these are factors of 12. This makes it easy. You'll get a lot of these like this. So notice, if I want to get the x-intercept, I plug a 0 in for what? So if I want to find the x-intercept, I'll plug a 0 in for y, and what happens now to this piece? It's gone, and I have 3x equals 12, and now I can easily see what x has to equal. X has to equal to what? 4. That's the only way that that's going to work. So I can quickly get the x-intercept, which is now 4, 0. Okay? All right, everybody see how I got that? Because if I plug in a 0 for y, that's gone. 3x is 12. I solved. If I want to get the y-intercept, I plug a 0 in where? For x. Now that's gone. 4y equals to 12, so y equals to 3. So now the y-intercept is 0, 3. And once you have both of those, you can graph it pretty easily. Because now you know the y-intercept is 0, 3. 1, 2, 3. The x-intercept is 4, 0. You have 2 points. If you have 2 points, can you make the line? Yes. There you go. So for me, the best thing to use with general form is to find the x-intercept and the y-intercept pretty quickly. I usually just do this and this. Okay. Does that make sense there? Good? Easy? Boring? Almost done. We'll do one application problem and that will kind of wrap it up. And I think you can go from there. One thing though, we do need to address vertical and horizontal line before I do this, because how do you write the equation if the slope is undefined, right? How do I use this? Because you do not plug in an undefined, I'll tell you that right now, because you mess up the whole equation. So how do I handle the equations of vertical and horizontal lines? Because notice every line we've been working with is either negative slope or positive slope. It's not horizontal or vertical. So just to elaborate on those real quick, we're almost good? All right, I need to know where I can erase. Can I erase up here, over here? Mm-hmm. Okay. All right, it's on film, so you're gonna get the film. Okay. So real quick, for a vertical line, I want to know how can we write the equation and what's always the slope. So let's just say your vertical line goes through the point 6,1, right here. Of course, we said earlier that the slope of a vertical line is always what? Undefined. And I say I want you to find the equation. So we know slope is undefined. How do you get the equation? Don't go over here and try and do this. Well, I got a point and I know the slope is UND. You can't plug a UND in. Right? Because if you plug in an undefined, it just messes the whole problem up. You can't evaluate from there. So notice this. I'm going to ask you a question, you're going to answer the question, okay? Wherever I point on this line, I want you to tell me the x value for the coordinate that I'm pointing to. So x is always what? There's your equation. X is 6. For vertical lines, the equation is always x equals, and that's why. Make sense? All right. Here's your horizontal line. Not that, but this. Same point, here's your horizontal line. So for the horizontal line, our slope is what? 0. So for horizontal lines, we can see that if we want to get the equation, we know that the slope is always 0. I'm going to point, one coordinate never changes. On the horizontal line, what never changes? The y. So no matter where I point, what's the y? So y is always 1. So on horizontal lines, it's always y equals to y. Vertical lines, it's always x equals to x. And that's how you can get the equation. All right. Last problem. Application problem. All right, this is the percentage of males that are unmarried. So, and it's like the age is 25 to 29-year-olds. But it's the percent that are unmarried based on the year. And year 0 is 1980. So we go 1980, 85, 90, 95, 2000. So if this is 2000, we won't call this 2000, we'll call this time as 20. So we'll use how many years since 1980, okay? And then we'll use 2005, but we'll use time as 25. So the years since 1980 will be our time, and the y's are the percent that are unmarried. So in the year 2000, it said that about 51% are unmarried. So this is the point 2051. Okay? So about half of the male. I told you I fudged this a little bit, so this data is not exactly right. And in 2005, it's about 61%. So 25 years since 1980, 61%. So there's a linear trend that they're saying on the percentage of males that are unmarried between 25 to 20. Well, you can't just keep going like that forever, right? Because you you're not gonna have 100% of the males not married, right? Just saying though, but less and less are, probably people are getting married when? When are they getting married? Yeah, in their 30s, later in life is what they're waiting, okay? So, what I want you to do is this. First, part one, part A, find the slope. Part B, write the point slope formula. And just use whatever point you want and write the slope intercept form. Do those three things. So using that data, sorry, it's not the best, that's 2561. 2561. 2561, because that's 25 years since 1980, 61% are unmarried. That's just made up. Okay. So find the slope, find the point, write the point slope form out. Don't simplify, just write it out, and then use that to get your slope intercept. Does that make sense? Oh man. Okay, did you guys get the slope? What is it? 2, but technically it's 2% per year. It's good to put the units so that it can kind of make sense for the problem. It's 2, but if I put the units, it's 2% per year. Because if you look at the units for this, right, the y's are percent, 61 minus 51. The x's are the years, 25 and 20. So you got 10 over 5, which is technically 2% per year. Because if you ever get questions like, well, what does the slope stand for? Well, it's telling you as every year goes by, what's happening to the percent of unmarried males? Goes up by 2%. That's what this is telling you. For every 1 year, the percent of unmarried males goes up 2%. Because in 5 years, they went up how much? 10. It's a slope. That's what slope tells you. It's a indication of the trend of the data. Okay? All right, now write your point slope. I would just use this first point. Y minus 51 equals 2 times x minus 20. Then so that's it for part B. You stop. That's point slope. Then you solve for y to get your part C. What did you get? 2x plus 11. Okay, there's that. Now, what might be a use for this? So for the line there, I might use predict percent unmarried in 2015. So how would you do that? What would you do? What would you do here?
You plug 4, 20, 35.
35 in for X. Here's, remember we said where you evaluate. So remember, the horizontal axis is the years since 1980. So 2015 is gonna be 35 years, so I don't plug in 2015, I plug in 35. And of course, now you can see why this data doesn't make sense. Cause that'd be how many, what percent is unmarried? Yeah, it's a lot. That's not gonna happen, I doubt it. Yeah, all right, but you could have at least predicted. Okay? All right, so that's a little bit for